Calculate the initial concentrations. The dimerization of nitrogen dioxide gas is represented by the equilibrium equation. Number 2 is in equilibrium with N2O4 because the volume of the rigid reaction vessel is exactly 1.00 liters. The initial molarity of the reactant is equal to its initial moles. Number 2. 0 is equal to 0.0300 moles over 1.00 liters equals 0.0300 molar initially. No product is added, so the starting concentration of the product is N2O40 is equal to 0 molar. Determine the equilibrium concentrations using an IC, initial, change, equilibrium, table. Let X represent the molarity of N2O4 produced at equilibrium. Since the stoichiometric ratio of reactant to product is 2:1, every mole of N2O4 that is formed requires the consumption of 2 moles of number 2. Begeneral CCCIC and number 2 and is in equilibrium with and N2O4 haline textex initial and 0.0300 molar and N0 molar textex change and -2x and N plus X textex equilibrium N 0.0300 2x and in X in array solve for the change variable X. We are given that at equilibrium the vessel contains 0.00500 moles of N2O4. Since the volume is 1.00 liters, the equilibrium concentration of product is N2O4. EQ equals X equals 0.00500 molar. Calculate the equilibrium concentration of the reactant. Number 2, EQ. Substitute the value of X into the equilibrium expression for number 2. Number 2, EQ equals 0.0300 molar. 2, 0.00500 molar. Number 2, EQ equals 0.0300 molar. 0.0100 molar equals 0.0200 molar. Formulate the equilibrium constant expression, Kc, based on the law of mass action. The equilibrium constant expression for this reaction is Kc equals N2O4 EQ over number 2 EQ to the power 2. Compute the numerical value of Kc. Substitute the calculated equilibrium concentrations into the expression. Kc equals 0.00500 over 0.0200 to the power 2 because calculators are not permitted on section 1 of the AP exam. Simplify the arithmetic using scientific notation. Kc equals 5.00 times 10 to the power negative 3 over 2.00 times 10 to the power negative 2 to the power 2 is equal to 5.00 times 10 to the power negative 3 over 4.00 times 10 to the power negative 4 Kelvin. C equals 5.00 over 4.00 times 10 to the power 1 is equal to 1.25 times 10 is equal to 12.5. This mathematically identifies option D as the correct answer. The correct answer is option D, 12.5.